In this video, I will explain the concept of plane waves, properties of a uniform plane wave. Electric and magnetic fields are perpendicular to each other. Electric field is represented by E bar, and the magnetic field is intensity is represented by H bar. E bar and H bar are perpendicular to each other. No electric or magnetic field in the direction of propagation. Suppose the wave is traveling along the z direction, therefore Ez and Hz are zero. No electric or magnetic field in the direction of propagation. Transverse electromagnetic wave, that is electric field and magnetic fields are perpendicular to each other. That is TEM wave. The value of magnetic field is equal to the magnitude of the electric field divided by E naught, 377 ohms at every instant. Magnetic field amplitude is much smaller than the electric field amplitude. E by H. E by H is equal to, in free space, 377 ohms, eta naught. E by H. Therefore, the value of magnetic field is equal to the value of magnetic field is equal to the magnitude of the electric field, E bar divided by eta naught, that is E bar divided by 377 ohms. Next one, uniform plane wave. An electromagnetic wave originates from a point in free space, spread out uniformly in all directions, and it forms a spherical wavefront. This is from that point source, the electromagnetic wave spread out uniformly in all directions, and it forms a spherical wavefront. An observer at a large distance from the source, this is the source, large distance. An observer, this one is observer. An observer at a large distance from the source is able to observe only small part of the wave. This is the wave. This is the wave, electromagnetic wave. Perpendicular electric and magnetic fields are perpendicular to each other. An observer at a large distance from the source is able to observe only small part of the wave, and the wave appears to him as a plane wave. Observe the small part of the wave, and the wave appears to him as a plane wave. For such a wave, that means plane wave, electric field E and magnetic field H are perpendicular to each other and to the direction of propagation. Important definition of uniform plane wave is a uniform plane wave is one in which electric field component E bar and magnetic field intensity component H bar lie in a plane and have same value everywhere in that plane at any fixed instant. The value is same at everywhere in the plane at any fixed instant. This is the wave propagation, electromagnetic wave propagation along z direction. There is no Ez component and Hz component along z directions. That means Ez is equal to 0, Hz is equal to 0. There is no variations along x direction and along y directions. Dou by dou x is equal to 0. Dou by dou y is equal to 0. Here blue lines indicates electric field components and red line indicates magnetic field components. This blue line and the red line perpendicular to each other in the direction of propagation. The direction of propagation wave is along that direction. Now I will concentrate on a solution of that uniform plane wave. Consider the second Maxwell's equation. The second Maxwell's equation. Del cross E is equal to minus dou B by dou T. Del cross E is equal to minus dou B by dou T. B is equal to mu H. We know that B is equal to mu H. Magnetic flux density B minus dou mu H by dou T. Take curl of that equation one. Next one, take curl of this equation 1. That means del cross E is equal to del cross minus dou mu H by dou T. That is equal to mu minus mu dou by dou T of del cross H. That is equal to minus mu dou by dou T of del cross H is equal to J plus dou D by dou T. Del cross H. First Maxwell's equation. Maxwell's equation in time varying fields. This is the conduction current density and the displacement current density. That is equal to mu minus mu dou by dou T. J is sigma E bar, but D is equal to epsilon E, epsilon dou E by dou T. This is the del cross E. Solve this identity. Del dot E minus del square E is equal to minus mu dou by dou T of sigma E plus epsilon dou E by dou T. Bring this side del square E in this direction. Del square E minus here del square E is equal to del dot E plus mu epsilon, here mu sigma dou E bar by dou T plus mu epsilon dou square E bar by dou T square. For any media, conducting media or any non-conducting media, the rho v is 0. Del dot D is equal to rho v. Del dot D is equal to epsilon E is equal to rho v. Del dot E is equal to rho v by epsilon. Rho v is equal to 0 by epsilon, that is equal to 0. Finally, del square E is equal to mu epsilon dou square E by dou T square plus mu sigma dou E by dou T. This is the similarly consider the Maxwell's first equation and solve this equation by using that after so many modifications. Del square H is equal to mu epsilon dou square H bar by dou T square. H bar is important. That is mu sigma dou H bar by dou T. Suppose a uniform plane wave traveling in z direction in free space. Suppose a uniform plane wave, traveling in z direction in free space, z direction in free space. In free space, sigma is equal to 0. In free space, sigma is equal to 0. Substitute sigma is equal to 0 in that equation, either del square E or del square H. Consider del square E, first equation only. Del square E is equal to, we know that del square E is equal to mu epsilon, so mu epsilon dou square E by dou t square, dou square E by dou t square plus mu sigma dou E by dou t, mu sigma dou E by dou t. But in free space, mu is equal to mu naught, epsilon is equal to epsilon naught, sigma is equal to 0 in free space. Substitute these conditions in the above equation. Del square E is equal to mu naught, epsilon is equal to epsilon naught, dou square E by dou t square, sigma is equal to 0. That means plus 0. This is the wave equation for free space. E bar, this is E bar is equal to AX, EX, AY, EY, AZ, EZ, AZ, EZ. Del square is equal to dou square by dou x square, dou square by dou y square, dou square by dou z square. Suppose a uniform plane wave propagating in z direction, it will have Ex and Ey components, but not Ez component. Consider a uniform plane wave propagating in z direction. It will have Ex and Ey components. Ex and Ey components, but not Ez. But no Ez component. That means Ez is equal to 0. Similarly, it will have Hx and Hy components. But no Hz component. Therefore, Hz is equal to 0. There is no variation of the field components along x and y directions. There is no variation. Of the field components along x and y directions. That means dou by dou x is equal to dou by dou y is equal to 0. This is the wave propagating in along z directions. E and H are perpendicular to each other. Consider the free space propagation. In free space, mu is equal to mu naught, epsilon is equal to epsilon naught, conductivity sigma is equal to 0. Substitute these conditions in the equation. This is the final equation. Del square E is equal to, consider electric field component only. we will consider magnetic field component also. In this expression, I will consider electric field component. Del square E bar is equal to mu naught epsilon naught dou square E bar by dou t square. But del square is equal to dou square dou x square plus dou square dou y square plus dou square dou z square. E bar is Ex Ax bar Ey Ay bar plus Ez Az bar is equal to mu naught epsilon naught dou square by dou t square Ex Ax Ey Ay Ez Az. Here need not write here. But the wave is propagating in along the direction Ez is equal to 0. Here Ez value is 0. This term is 0. Here variations. That means dou by dou x is equal to 0. Dou by dou y is equal to 0. This value is 0. This value is also 0. Finally, dou square by dou z square. Here also Ez is equal to 0. Ex Ax bar Ey Ay Ay. That is equal to Ey bar Ay is equal to mu naught epsilon naught dou square by dou t square dou square by dou t square Ex Ex Ax plus Ey bar Ey bar Ay. Therefore, dou square Ex by dou z square Ax plus dou square Ey Ay by dou z square mu naught epsilon naught dou square by dou t square Ex bar Ax plus Ey bar Ay. Equating these expressions. Therefore, dou square Ex by dou z square Ax means here mu naught epsilon naught dou square by dou t square Ex, and one more expression is dou square Ey by dou z square is equal to mu naught epsilon naught dou square by dou t square Ey bar X bar. Similarly, for H bar, for h bar. Therefore, dou square hx by dou z square is equal to mu naught epsilon naught dou square by dou t square hx bar dou square hy by dou z square is equal to mu naught epsilon naught dou square by dou t square hy bar. This is the wave equation for uniform plane wave in free space traveling in z direction. These are the equations. Solution of wave equation. Next one is solution of wave equation. Solution of wave equation. Uniform plane wave traveling in z direction in the free space. Therefore, this is the dou square ex by dou z square is equal mu naught epsilon naught dou square ex by dou t square. But c is equal to velocity of wave in free space is c is equal to 1 by square root of mu naught epsilon naught. Mu naught epsilon naught is 1 by c square dou square ex by dou t square. Therefore, dou square ey by dou z square is equal to 1 by c square dou square ey by dou t square, where c is called as the velocity of the wave in free space. The general solution of such a differential equation has the form. The general solution of such a differential equation. Such a differential equation has form E is equal to electric field. Consider electric field only here. F1 into Z minus Ct plus F2 into Z plus Ct, where F1 and F2 are any arbitrary functions of Z minus Ct and Z plus Ct. Here F1 and F2 are any arbitrary functions of Z minus Ct and Z plus Ct. This is the solution. The first function represents the wave traveling in positive z direction, while the second term represents the wave traveling in negative z directions. The first term represents a wave traveling in positive z direction. While the second term represents the wave traveling in negative z direction.